Constellations. There are trillions of stars in the sky. Some of them form constellations, certain areas in space that simplify orientation in the sky. Since ancient times, people have noticed that luminous points line up certain patterns, and sometimes figures. Moreover, at a certain time period, they are in the same position in space. Constellations have simplified this process throughout the study of space. Now, most of them, located at a visible distance from the solar system, are well studied. What are constellations? A constellation is a set of stars arranged in a certain shape. In ancient times, this term meant patterns in the sky that vaguely resembled mythical creatures or certain objects. It is by this principle that many of them received their names, used by astronomers to this day. What are asterisms? In addition to constellations, there are also asterisms. These concepts are quite close in meaning, but have certain differences. Asterisms are groups of stars that are part of a certain constellation and form an easily recognizable shape that can be easily seen in the night sky even with the naked eye. Asterisms do not have an official list since they were compiled by amateur astronomers. Interesting fact, the most famous asterism is the Big Dipper, which is part of the constellation Ursa Major. Its shape, consisting of 7 stars, is easily recognizable in the dark. In the past, in Russia, astronomers classified asterisms not only as groups of stars arranged in a certain shape, but also as clusters of stars that are easily discernible with amateur optics. It can be said that asterisms appeared to simplify the study of the star map for those who did not have advanced technologies for space exploration. Using them, astronomers can easily determine the location of the main celestial objects and begin further observation. At the moment, there are 28 main asterisms, 23 of which are part of different constellations. The remaining 5 are large clusters of stars. What is the difference between asterisms and constellations? As mentioned above, there is a relatively small difference between asterisms and constellations, which is why a person who does not understand the specifics of space exploration can confuse them. In order to draw a clear line between the terms, it is better to understand the meaning of each separately. A constellation is a cluster of stars located in a certain area. Moreover, it includes not only the luminaries that form a pattern, but also the rest that are located in a certain proximity. People in ancient times noticed that some stars in the sky can be combined into a group, due to which the first constellations began to appear. Interesting fact, the first constellations were compiled by the Greek writer Aratus, who described them in 270 BC. Claudius Ptolemy made a great contribution to the compilation of constellations. He spent a lot of time studying the sky and looking for groups of stars that line up in patterns. Around 150 AD, he discovered and described 48 constellations that are still used by astronomers to navigate the sky. Most of them are named after mythical Greek creatures and animals. In the period from the 16th to the 18th centuries, with the advent of the first telescopes, interest in space began to grow. Many astronomers studied the sky and tried to find new constellations. At that time, clusters denoting the signs of the Zodiac, as well as star groups from Orion's belt, were added to Ptolemy's discoveries. Astronomers from different parts of the Earth were constantly making new discoveries. However, it quickly became clear that the newly minted constellations were either already known or were part of an already discovered one, and there were many of the latter. Because of this, the concept of asterism appeared. Asterisms are part of a constellation and represent its base, consisting of the most noticeable stars. It is this that can be seen through an amateur telescope. And since not every astronomer had professional equipment at that time, he had to admire the asterisms, while the other, not so bright stars of the constellations remained hidden from view. How did the names of the constellations appear? The constellations got their names for a reason. Each name has a certain meaning. When Ptolemy compiled a list of the first star clusters, he understood perfectly well that they needed to be given catchy, memorable names. Since mythology was highly developed in ancient Greece, he decided to give them names referring to this culture. Very quickly, the astronomer drew parallels between the shape of the constellations and the appearance of significant animals and gods. This is how Andromeda, Aquila, Aquarius, and many others appeared in the sky. Interesting fact, the constellation Capricorn, discovered by Ptolemy, denotes the god Pan. But in ancient times it was also called Almatia in honor of the goat that fed Zeus in infancy. Ptolemy named each of the 48 constellations he discovered. Since then, astronomers have also come up with names for their discoveries. A great contribution to this was made by de Houtman and Dirk Exelon, who in the 16th century named new star clusters after exotic animals. This is how the chameleon, goldfish, toucan, etc. appeared. In the 18th century, when astronomy became even more developed, scientists began to pay tribute to the instruments with which one can study the map of the starry sky. For example, Nicolas Louis de Lacca added the angle, circonus, and telescope to the list of constellations. It is worth noting that these star patterns really resemble these objects in shape. Zodiac constellations. A person is born during a certain zodiac sign. But not everyone knows that they have their own constellations, called zodiacal. Moreover, if even children know the 12 zodiac constellations, then Ophiuchus joined this group quite recently. How did they appear? The first star map was discovered in a cave in France. On the wall, primitive people left primitive drawings on which they depicted the sky. But even on them you can see the outlines of the constellations. The Babylonians, who lived 3,000 years ago, also paid attention to the stars and made maps. Their developments were used by the ancient Greeks, supplementing them with a lot of details. Even then, among the known constellations, there were zodiac ones. These clusters are used to determine the boundaries between the changes of the year. Since the Earth revolves around the Sun, certain stars are visible at different times. This rule also works with zodiac groups. For example, at the end of October, you can clearly distinguish the zodiac sign in the form of Scorpio. In the past, this helped people determine the time of year and month. How many constellations are there in the sky? At the moment, there are 88 constellations in the official list, which occupy a certain area in the sky. Despite the fact that astronomers explore space in more detail with each passing decade, classifying star clusters is not so easy. Since stars simplify orientation in space, there is no point in adding a new group to the official list if it is located at a large distance from the Earth and is practically invisible. And those stars that are far enough from the planet to serve as beacons are most likely part of a certain cluster. Perhaps in the future, the number of constellations will increase, but for this to happen, new stars must appear in the sky. Northern and southern constellations. The Earth rotates around its axis at a slight angle, so only certain constellations are visible on the hemispheres. Depending on which half of the planet they are visible on, they belong to the southern or northern group. There are currently 52 southern and 36 northern constellations. For example, Microscope belongs to the first group, and it cannot be seen on the other hemisphere. This is due to the fact that when it appears above it, it will already be daytime. And if a resident of the northern hemisphere goes outside and looks up, he will only be able to see a blue veil. But there are exceptions. For example, if the position of the northern star group is close to the equator, then it can be seen on the horizon of the southern hemisphere. This rule also works in the other direction. Interesting fact, Canis Major and Sirius can be seen on the horizon of the southern. The same applies to Hydra, Cetus and Monoceros, visible on the northern half of the planet. Movement of celestial objects by constellations. Since the stars that make up the constellations are at a great distance from the Earth, their movement in space is almost imperceptible. And since these clusters are motionless relative to the solar system, people have learned to determine the movement of nearby celestial objects by constellations. Thanks to this, it was established that the moon gradually moves from west to east, falling into the area of different constellations over time. In 24 hours, it shifts by 13 degrees and makes a full rotation in 27 days, falling into the boundaries of 12 star groups. Interesting fact, the sun goes through a full circle in a year, shifting by about a degree per day. Constellation boundaries. Up until the 20th century, the constellations did not have clear boundaries. Astronomers already then identified 88 clusters, but some stars located between two neighboring ones could be attributed to different groups by different scientists. A clear division of the boundaries of the constellations appeared in 1922. American astronomer Henry Norris Russell identified individual areas for each of them. 8 years later, the Belgian scientist Eugene Delporte added vertical and horizontal lines to the star map, supplementing Russell's division with clear boundaries. But it is important to understand that although there are fixed areas, they perform a conditional function. The star map is a plane where celestial bodies are plotted, but in reality they are located in three-dimensional space and are at different distances from each other, and not on the same line. Also, light reaches the Earth with a delay, which is why the objects visible now may in reality be at a different point or no longer exist at all. History of constellations. Since constellations appeared in ancient times, they have a rich history. Observing star clusters, the ancient Greeks managed to discern gods, mythical animals, and other creatures in them. That is why most of the names of constellations come from their culture. The word constellation comes from the Latin constellatio, which can literally be translated as many stars. Its first mention appeared in the 4th century in the manuscripts of Ammianus Marcellinus. Interesting fact: for a long time, clusters of planets were called constellations. Only since the 16th century has this term been applied to stars. The Babylonians were the first to see constellations in the sky. The Greeks borrowed their work, and Ptolemy identified 48 star clusters. However, due to the geographical location, he was only able to see the northern constellations. The southern ones were added to the general list by the Dutch travelers de Houtman and Keizer in the 16th century, and in 1603, Johann Bayer compiled a detailed star atlas, which included all known constellations. He also gave names to many stars, using the Greek alphabet. In 1756, the French astronomer Louis de Locke published his version of the book, making it more detailed and adding 13 more constellations. Thus, their number became equal to 88 and has not changed since then. Milky Way Galaxy. The Milky Way Galaxy is of greatest interest to astronomers because it contains the solar system in which the Earth is located. This group includes all the stars that the human eye can see without additional technology. Astronomers study the Milky Way every day and make discoveries that help create an overall picture of the structure of the cosmos. What is the Milky Way? While studying space and galaxies, Edwin Hubble discovered that they can have two types of shapes, spiral and elliptical. The former visually looks like a rotating disk made up of curved arms tightly connected to each other. The Milky Way also belongs to this type. Before the invention of radio telescopes, mankind had no way to accurately determine the size and shape of a galaxy. Because there is dust in space, it blocks the light of stars. This leads to errors in the study. However, these telescopes allow the observation of radio waves in the sky. The invention helped to determine the exact distance to most of the stars in the Milky Way and to determine their speed. When the information about each object was combined, it turned out that they all rotated in a spiral and were located in a separate arm. Milky Way main features. One of the galaxy's main features lies in its name. According to ancient Greek legend, the Titan Kronos ate the children that Rhea gave birth to. The mother mourned greatly, and when the 5 children were eaten, she decided to save Zeus, the last son. Rhea wrapped the stone in a blanket and took it to Cronus. He groped the curdle and asked to feed the baby to gain weight. The girl splashed milk on a rock and it bounced off, appearing in the sky as the Milky Way. When Zeus grew up, he defeated the Titan and became the head of the gods. Another property of the galaxy is the ability to absorb others. Several constellations in different constellations gradually move through the Milky Way. They fall under the influence of the Milky Way and reach out to embrace it. However, Galax is not always attracted to his younger brothers. Now he is already communicating with Andromeda, which is much larger. Scientists believe that in 3 to 4 billion years both galaxies will collide and the Milky Way will be absorbed. The main characteristics and parameters of the Milky Way. Since the solar system is located inside the Milky Way, this galaxy was the first galaxy studied by scientists when the proper methods became available. It is now well studied and most of its parameters are determined as accurately as possible. Structure and composition of the Milky Way. In the center of the galaxy is a bright nucleus formed by billions of stars. Its size is difficult to measure, but scientists believe that it is several thousand parsecs. 1 par equals 86 trillion km. It is also believed that there is a black hole at the center of the Milky Way. The center of the galaxy is crossed by a bridge 27,000 light-years long. It is also located at an angle of 44 degrees to the Sun. The Milky Way consists mainly of stars, dust, gas, and constellations. In addition, young objects are moving away from the center. The Milky Way is surrounded by a dark halo of dwarf galaxies and star clusters. They hit such a large object and rotate relative to it. The outflows move in the middle, forming a spiral disk. Therefore, the galaxy is fairly flat when viewed from the side. Size. The Milky Way is usually thought to be 100,000 light-years in diameter and 1,000 light-years wide. But a few years ago, researchers from the Canary Institute conducted a detailed study and found that the galaxy could be 200,000 light-years in diameter. In 2020, astrophysicists completed a new study according to which the new diameter of the Milky Way could be 1,900,000 light-years. However, this information has not yet been confirmed. Number of stars. How many stars are there in the Milky Way? The Milky Way contains about 400 billion stars, most of which are in neighboring branches. In addition to them, there are 25 to 110 billion brown dwarfs living in the galaxy. Their brightness and magnitude are not enough to classify them as full-blown stars. Mass. The halo around the Milky Way contains dark matter, which makes up most of the mass. This makes it difficult for researchers to calculate an exact value. In 2009, the galaxy's mass was estimated at 6×10^32 kilograms. But 10 years later, more detailed studies were done. In 2019, this parameter was proven to be 2 times larger, around 130,000 light-years. The disk. To study the Milky Way disk in more detail, scientists continue to develop universal techniques. Thanks to this, it is possible to observe objects at a great distance and obtain new information. Interesting fact, it was only in the 1980s that the Milky Way was discovered as a kind of spiral galaxy. The final confirmation of this was obtained using the Lyman-Spitze telescope in 2005. The disk is 100,000 light-years long and is constantly rotating, with some areas rotating differently. In the center, objects are in a static state, but as they move away, some stars begin to move at a speed of 200 to 230 kilometers and even faster. The flat disk consists mainly of young stars that are less than a few billion years old. The arms themselves are 10 billion years old. More mature objects are farther away from the Milky Way. Core. At the center of the Milky Way is a large 27,000 light-year-long globular seal called the bulge. It is believed to contain a large Sagittarius black hole and another medium-sized hole. They are surrounded by stars that make the core shine. The center of the galaxy is crossed by a bridge of mostly red stars that are very old. In 2016, Japanese astronomers discovered a giant black hole 200 light-years away with a mass of 100,000 suns. And 2 years later, 12 systems near the core were found that could also have black holes inside. Sleeves. Because the Milky Way is a spiral galaxy, its arms are in the plane of the disk. They are surrounded by a halo, also called a corona. Because the solar system is located in Orion's arm, inside the disk, scientists can't see its structure from the outside. But advanced research using the properties of hydrogen is helping to build a theoretical picture of what these arms might look like. They are expected to be close together and may also contain duplicates that share a common region. And not too long ago, astronomers put forward a theory that the Milky Way may have a four-arm structure. Halo. The halo surrounds the Milky Way disk and is spherical in shape. Its range in different directions is estimated to be 5,000 to 10,000 light-years. It contains letters and letters of high age. Interesting fact, it used to be thought that the most distant stars were 100,000 light-years away from the core of the Milky Way. However, objects 200,000 light-years away from Earth have recently been discovered. It is believed that the halo formed 12 billion years ago. This is evidenced by old clusters of up to 1 million stars. All objects inside the sphere rotate in elongated orbits under the influence of the disk. They can move in different directions, but their speed is always low. And while the latter contains a lot of gas and dust from which objects are formed, in the halo they are almost non-existent. Because of this, its structure is fully developed and no new stars appear in it. Location of the Milky Way in the universe. In 2015, researchers at the Hawaii Astronomical Institute decided to determine the exact location of the Milky Way in the universe. The galaxy is not only a member of the local group, but is also part of the Laniakea. This region covers 500 million light-years and contains hundreds of thousands of star clusters. But Laniakea is far from the largest object in the universe. This is just a part of the Keith supergroup, which in turn is part of the Pisces group, a region of space where a huge number of galaxies are concentrated. Scientists are still unable to accurately track the movement of objects on Laniakea. At present, the Milky Way is probably gradually moving deeper into the cluster. The Milky Way galaxy and its surroundings. Since the Big Bang and the creation of the universe, all objects in space have been in constant motion. Some of them are so old that they have already traveled most of their way, while others are still just forming. Just a few centuries ago, astronomers believed that the Milky Way was the universe and that there was nothing beyond it. But the invention of more modern telescopes has made the existence of other galaxies possible. The Milky Way is surrounded by objects belonging to the local group. The largest of these is Andromeda, which is twice as big. Also in the distance is the Triangle Spiral Galaxy. These objects are surrounded by their companions. They are represented as clusters of moving dwarfs. The local group also includes irregular and elliptical galaxies located in certain constellations. Class and general structure. By class, the Milky Way belongs to spiral galaxies with a junction running through the center. This type is considered the most common in the universe. Spirals make up about 56% of the total number of galaxies, and 65% of these have a junction. At the center of the Milky Way is an active nucleus, releasing a large amount of energy into space. Around it is a concentrated disk composed of gas, dust, and rapidly rotating objects. There is a bulge near the center where the jumper passes through. It consists of a large number of giant stars. Interesting fact, the bulge is the brightest component of the Milky Way, but its light cannot be seen from Earth because of the arms. A sweater with attached sleeves goes through the hole. It contains a large amount of gas, so new stars continue to form here. Objects inside the arms rotate at different speeds, and the local region of the solar system can be called the quietest. There are no large clusters of galactic dust negatively affecting stars and planets. The visible disk of the Milky Way is surrounded by a halo, a giant spherical region containing individual clusters. They also move relative to the center of the galaxy, but much slower and more chaotic than objects inside the disk. Not long ago, astronomers discovered that the clusters inside the halo are former dwarf galaxies absorbed by the Milky Way. The place of the Sun in the galaxy, as mentioned above, the solar system, is not the core of the Milky Way. The Sun appears between the arms of Sagittarius and Perseus. Their spiral branches are 4,000 light-years away. The solar system is closer to the edge of the galactic disk than to the center. Its distance from the latter is about 28,000 light-years. The Sun gradually moves around the core of the Milky Way, making one revolution over 220 million years. This suggests that the Earth has circled the galaxy about 30 times since its appearance. The Sun is located in the region of the Milky Way where the spiral arms and stars move at the same speed. Therefore, the star and planets are not constantly exposed to gas, dust, and other substances. Scientists believe that the solar system is very lucky to appear in this region, because otherwise the existence of living things on Earth would be impossible. Location of stars. All the stars that the human eye can see in the sky are located around the Orion arm. In total, in good light, about 900 stars can be seen. In the center of the galaxy there is a large number of luminaries, which is why it emits such a bright light. Next, younger objects belonging to different constellations and belonging to the same arm are distributed across the disk. There are also stars in Hula, but their number is very small compared to the living ones in the middle. While there may be several billion arm groupings, the number of them in the dark region is in the millions. In addition, most of the stars in the halo have already lived more than half of their lives and are considered very old. The history and future of the Milky Way. Scientists cannot say the exact age of the Milky Way, but the galaxy is considered quite ancient. The proof of this is the star HD 140,283. It is in its own region and is only 100 million years younger than the universe. It has been found that all the matter in the Milky Way's space and what makes up its stars used to belong to other stars. However, the latter did not last long and exploded. The gases released from the atmosphere gradually attracted each other until they formed a galaxy. When the Milky Way formed, it began to swallow its companions, the dwarf galaxies. Even now, its south pole is gradually absorbing gases from both Magellanic Clouds. According to scientists, the galaxy has already lived half of its allotted time. There is almost no gas in its regions to form new stars. However, the latter are still quite young, so they can exist for quite a long time. The stars begin to fade after about 5 billion years, and that's when the Milky Way begins to approach Andromeda. Both galaxies are experiencing mutual absorption, but because of its larger size, the latter has a better chance of emerging victorious from this confrontation. However, astronomers do not guarantee that events will follow this scenario. Given that they are still a few billion years away, things can change dramatically in that time. Mythology. In the mythologies of different countries there are their own legends about the appearance of the Milky Way. In some Arab countries, there is a story about the god Vahagni who stole straw from Barsham and hid in the sky. Escaping, it gradually lost the branches and reeds from which the galaxy was formed. In Hungary, They believe that the stars of the Milky Way are sparks from the hoof of Attila's horse, who descended from the sky to help the scholars. In India, it is believed that the galaxy was born when a pink cow poured milk into the sky. In China and Japan, there are myths that the Milky Way is a river flowing through the sky. In Maori mythology, he was thought to be the boat on which the gods sailed across the sky. The Native Americans were convinced that the galaxy was made up of ashes. There was one particularly absent-minded girl who wanted to show the soldiers the way home. In Finland, it was believed that the Milky Way was born as a result of birds flying in the sky. Other countries also often associate the appearance of the galaxy with birds and their ability to fly. Black holes. The most mysterious objects in space. What is the nature of black holes? It may seem strange, but black holes are already questioned from the point of view of elementary objects in the universe by their characteristics. They decide only two parameters: rotation speed and mass. In astrophysics, it is claimed that they are the final stage of the evolution of stars. When a star completes its life cycle, an explosion occurs, and its center turns into a black hole. The surface of a new astronomical place is called an event. It is important to understand that a black hole does not have a physical surface. This term only means some distance from the center, where the attraction ends. When we cross the border of events, they cannot leave the black hole due to the strong gravitational field. Interesting fact, to leave black holes, an object must move in the opposite direction of time, that is, move into the past, which is basically impossible. Why did black holes get this name? At first, these space objects were called collapsers, but in the 20th century, science journalists began using the term black hole. Physicist John Wheeler liked it so much that it became the official name. Black holes got this name because they completely absorb light, making them impossible to see. They can only be seen if there is a shell of certain substances, such as gas, around the event horizon. They can be killed if they absorb matter and energy from a neighboring country. Otherwise, they cannot be detected because they are invisible to the human eye and instruments. Although black holes absorb light without reflecting it, they can emit it tomorrow. During its existence, a black hole can generate various elementary particles in space, mainly photons. From a physical point of view, this process resembles evaporation. At the moment, this phenomenon has not been confirmed, but there is only a theoretical model. Scientists call it Hawking radiation. Black holes become visible when they meet each other, which causes curious gravitational waves in space. How do black holes appear? The formation of black holes directly depends on their mass. According to this parameter, they are divided into two categories: circumsolar, their mass is comparable to local communities, and massive, their mass is several times greater. Studies have shown that circumsolar black holes are old and probably appeared in the early stages of the formation of the universe. They were formed as a result of the compression of stars, the sizes of which are 25 to 70 times larger than the Sun. When a star ends its existence, it explodes, and its center turns into a black hole. Massive objects, as a rule, are formed from giant gas clouds. The mass of these clouds allows massive black holes to be distinguished, which weigh millions of times more than the Sun. In the Milky Way galaxy, there is a black hole called Sagittarius asterisk. It is located 26,000 light-years from our solar system. This era was formed at about the same time as the galaxy and is located in its center. The main material for it was a gas cloud, which was compressed to a small size. There is also a version that the black hole in the Milky Way appeared after the explosion of a giant star of the lights. During their existence, both types of objects attract matter from space, crossing their event horizon, and because of this, the dimensions of black holes gradually increase. Moreover, if absorption occurs only on one side, the black hole begins to rotate in a certain direction. What is the shape of a black hole? All black holes rotate around their axis, and their appearance depends on the speed of rotation. If the rotation is slow, the shape of the object will be spherical. But if the black hole rotates quickly, its poles are flattened, which makes it oval. At the moment, existing technologies are good enough to determine the shape of the object, but scientists have not yet been able to uncover the secret of the contents of the center of a black hole. It is known that ordinary physical laws do not apply there, and the curvilinear space tends to infinity. So far, the most common hypothesis is the presence of a singularity inside the black hole. The structure and physics of objects known as black holes. Any black hole is a complex of two key components. First, there is the so-called event interval. This is the boundary that is crossed. The object was under the influence of a strong gravitational field. Second, the singularity is a region inside the black hole about which nothing is known for sure. It is only known that the usual laws of time and space are violated inside black holes. When a black hole begins to rotate, an atmosphere is created around the collisions. Objects located in this zone also begin to rotate with it. However, the gravity here is not strong enough to keep these objects inside the singularity, so they can end up far from the ergosphere. Fun fact: as the mass of a black hole increases, its density decreases, since the increase in volume occurs faster. Observing black holes is a difficult process that requires long-term observation and data collection. Many of them remain unnoticed until they begin to absorb the surrounding matter. The galaxy experienced approximately 10 black days ago. Lithuania was constantly monitored. However, there may be a large number of such objects inside the galaxy, including both small and supermassive ones. Interesting fact: there are approximately 400 million stars in the galaxy that can turn into black holes. In 2005, an inhomogeneous region was discovered moving around the center of the galaxy. According to data, there may be up to 20,000 black holes in this region. Recently, Japanese astronomers discovered an object near Sagittarius Asterisk, which has a mass of 100,000 solar masses and a diameter of 0.3 light-years. The largest black hole, known as FSRQ Blazer, is located in the galaxy S5014+81 and serves as its core. It is approximately 12 billion years old, weighs 40 billion solar masses, and has a diameter of about 0.26 light-years. The study of black holes is necessary for understanding the structure of space and its laws. Astronomers have discovered and studied about 10 black holes so far. If you fall into a black hole, nothing good will happen there. Under the influence of a strong gravitational field, the object will stretch and flatten until it breaks apart into atoms and merges with the singularity. Black holes can collide with each other after the extinction of a binary fever or during a galaxy merger. After merging, black holes become single targets, having large sizes. White holes are the complete opposite of black holes. Their main feature is that it is impossible to penetrate the event horizon. White holes are also called massless singularities because there is no matter inside them and they weigh nothing. White holes were first discussed in the 1970s, and since then astrophysicists have not given up hope of finding at least one in outer space. At the moment, scientists have not yet observed white holes, so their existence is determined only by theoretical data. While black holes absorb light and do not allow it to escape beyond the event horizon, white holes, on the contrary, throw it into space with such force that it is impossible to break through the radiation and end up inside. If such an object exists in reality, it has a high brightness, exceeding the same parameter for stars. In addition, there are several reasons indicating the impossibility of the existence of white holes. Firstly, during its life this object should gradually form from a singularity into a star. It turns out that it will emit a large amount of energy into space, but at the same time, it will also accumulate it. This is the same as if a hot object heated the space around it, but also maintained its temperature without outside help. At the moment, such a process is considered impossible. Secondly, the singularity inside the white hole must form independently and not appear as a result of the fading of the star. Its spontaneous formation is also considered unlikely. But there are hints of the existence of white holes in space. Among them are gamma ray bursts. This is a phenomenon during which a large amount of energy is emitted into space. Interesting fact: in 1 second, a gamma ray burst can emit as much energy into space as the sun emits in 1 billion years. How black holes disappear at the moment. Scientists have not yet observed the process of the disappearance of a black hole, so it is unknown whether this object has a lifespan. Stephen Hawking put forward a theory in which he tried to explain how this phenomenon can occur. It was called black hole evaporation. The essence of Hawking's theory is based on the appearance of virtual particles. These are paired microscopic objects that regularly appear in a vacuum. And if virtual particles are formed on the edge of the event horizon, they will break apart. One will fly to the center of the black hole, and the second away from it. In this case, the first particle will have negative energy. This means that the black hole will lose an amount of mass equal to its weight. And if such bombardment continues regularly, then gradually the celestial body will completely lose mass and disappear. but this process will take a long time. However, this theory has opponents, because if a black hole loses mass when absorbing an object, the loss must be compensated by the weight of the substance that has fallen inside. Why a black hole does not suck in a galaxy. Black holes located in the center of a galaxy gradually absorb the matter around it and increase their volume. But not a single case has yet been recorded where at least one object of this type completely sucked in an entire star cluster. The complete absorption of the galaxy does not occur due to the law of universal gravitation and a number of other reasons. A black hole has a gravitational attraction, but the farther away an object is from it, the weaker its influence is. Also, all celestial bodies located in the galaxy rotate in a circle, which slows down the absorption process. In fact, in this situation, the black hole acts as the sun, and the galaxy is the planets that revolve around it, but at a certain distance. If the evaporation theory is correct, then it can also explain why a black hole does not suck in everything around it. Having absorbed enough matter and energy, it should throw the same amount into space. Accordingly, a balance appears, at which absorption stops. Some matter near the black hole can still be drawn in, but most of the galaxy will not feel the influence of gravity. Why a black hole does not emit light. Black holes have such a large mass and gravity that space and time inside them are curved. Because of this, no object that crosses the event horizon can escape, including light. Therefore, black holes do not emit any radiation.